Talking. Can you hear me? Test 1, 2, 3. I can't hear you though. I can't hear the music either. Yes, I can hear you loud and clear. Who's this? Ah, it came back. I'm having trouble with my camera, Carl. It comes on and off. Funny, I heard myself almost a minute delay. It was me. That's me, Jeff.
Ah, yeah. Dig that groovin' trumpet. That was Doug Wolverton on trumpet in a little project that we're doing called Groove Chillers. Hope you like that. Hey, I'm Carl Franklin. It's Blazor time. We're doing a live stream here. This will be the second to last live stream we're doing. And for the month of May, I'm going to be focusing on little topic-based YouTube videos that will be spitting out all month. So that's going to be cool. But right now, I see some people in the chat room. Miguel Castro is out on YouTube. That's very cool. Carnegie Johnson is on Twitch. Good old friend of mine. And a friend of the family as well. Well, wow, this is it's very cool. Also, can I just give you some personal updates? I've been cleared of the coronavirus. I actually had it. I was tested positive in March 29th. And that was a couple of weeks after my symptoms had cleared up. I got symptoms when I was out on the road in early March with the Blazor Roadshow, which is a derivative of this. And yeah, I sort of self-isolated for quite a long time. And in fact, my wife went to stay with her sister. And I came home. That was the beginning of March. It was like the second week in March. And then I got tested and I was positive. But I just got cleared last week. So my wife is back home with me and life is coming back to normal. I hope your stories are as happy as mine is. So I know it's tough out there, guys. But anyway, let's get started, shall we? I would like to start by thanking my sponsor, DevExpress. They've been in the business for a long, long time and making developers more productive. And now they got some free Blazor components that you should definitely go check out at devexpress.com/freeblazor. Thanks, guys. So here's the story. I'm going to tell you everything I know about Blazor, at least as much as I can do in a couple hours. I actually have a full 2-day course on Blazor that I've been doing at NDC conferences, online, of course. Hey, who isn't online right now? And I pick and choose stuff from that. Obviously, I don't walk through building stuff. I'm showing you things that are already built. But at the end of this desk show, you will be able to make smart decisions on which platform you're going to use, the hosting model you're going to use. Maybe you'll do both. We'll talk about all of that stuff. You should have some good ideas as to how to scale it up and scale it out. And you'll have development ideas as to how to go about doing all the stuff you need to do in a web application. So it's going to be fast and furious. Don't worry about missing out, though, because you can get this slideshow and the hands-on lab and the source code that I've built. All of it is free at blazordeskshow.com. Just go there and download it and knock yourselves out. I'd also like to mention that a couple of my friends are in the chat room. John Martin from DevExpress, Don Weebier from DevExpress, and I think that's it. Oh no, Jeff Cosby is out there too. Jeff was our media guy, video guy, and driver on the Blazor Roadshow, and he's out there. So say hi to them, and they're fielding questions about Blazor so I can continue talking. So if you have any questions about stuff that I'm saying, just throw them out there. One of those guys will get back to you. Okay? Very good. So let's start with what Blazor is. To most of you, or to most people who have been sort of following the story of Blazor, it started out as a way to run C# in the browser. And yes, you can do that with one of the hosting models, the client-side hosting model. But it's grown into a this beautiful component model for the web. And you can have that component, well, the component is being markup, HTML, and C# code. And you can compile these into assemblies, and you can have child components within components, right? So with that whole component snap-in model is the idea. And you can even share these assemblies, and it's opened up a new market for Blazor controls. We call them components, but if you want to think of them like custom controls, that's essentially what they are. And there's a number of vendors, DevExpress being one of them, out there. So it's this model, and this hosting model, these Blazor components will run, the same code and markup will run on the server side and on the client side. So there's really two hosting models that have been built out of this. Yes, we have that client side model, which is the original vision of Blazor, all right, which is basically C# assemblies, .NET standard assemblies running on WebAssembly in the browser. All right, and I'll just hold that thought because we'll talk about WebAssembly in just a minute. And then you can take those same components and run them on the server. And how I mean that, I don't mean like some sort of API call or anything like that. No, we're just taking WebAssembly completely out of the picture with a server-side model. And essentially there's some magic secret sauce, some voodoo that happens so that there's no plumbing code necessary on your part. You don't even see it. It just sort of magically happens. So a button click that happens in the browser, the handler actually runs in the server, and there's no view state. There's none of that. It's a very lightweight. It's not, Web Forms 2.0, but it has the same appeal as Web Forms had in the very beginning, which is, hey, I don't have to mess around with the goo of web development. I can just focus on my UI and my event handlers and all of that stuff and the methods that I'm calling. So we'll talk about what that magic is in a minute. The same markup and code will run in both places in either model, but you have to pick a model. When you start a Blazor project, it's either going to be a Blazor server project or a Blazor WebAssembly project. You wouldn't combine them in the same project, and you don't want to. All right, this is a SPA framework. It's a UI framework, Blazor is. And so it's really just about how do we get from the button click to the event handler updating the browser, right? So that's the model. It's about binding, and it's about event handling and all of that stuff. So you don't want to combine these two things. You, of course, can have Blazor UI code wherever it resides that calls into APIs, which might reside on your server, might reside on another server. Of course, that's definitely possible. In fact, Blazor is just a UI model for any kind of .NET Core application. So on Blazor server, you're basically creating an ASP.NET Core web app. All right, but it just so happens to have the Blazor plumbing in it. Blazor client, you can actually host that from an ASP.NET Core 3.1 server. So either way, it's really just ASP.NET. All right. All right, let's talk about Silverlight. Let's talk about itchy nose. My nose itches whenever I don't know what it is. Maybe I'm allergic to webcams or something, but it seems like every time I get on camera, my nose itches. Let's talk about Silverlight, because I know Miguel Castro is out there thinking, Dad, this is bullcrap. It's just Silverlight, man. Right? Is that what you're saying, Miguel? This is the next version of Silverlight. I don't know if he thinks that or not, but there's a lot of people that, and I'm not saying Miguel is one of them. I'm just saying I can hear his voice, right? Saying that. Sorry, Miguel. There's a lot of people that just naturally jump to that conclusion that WebAssembly is, since it's C# in the browser, it necessarily has the same sort of architecture and will die the same fate as Silverlight did. So let's back up just a little bit and talk about what WebAssembly is. WebAssembly is a virtual machine that is baked into every modern browser. By modern, I just mean any browser that is continually updating and trying to stay current and in development, right? So that's Chrome, that's Edge, that's Firefox, Mozilla, Opera, on the iOS side, Safari, Apple Safari on the desktop. So it's in the browsers now. It's not something that the browser companies are opting into, it is there. All right. Internet Explorer stopped being in development before WebAssembly, so it does not support WebAssembly, but that's because it's not a modern browser. They actually stopped Internet Explorer and moved on to Edge, right? But there's a lot of companies that are still using Internet Explorer 11 for their software precisely because it supports some of the old stuff. And, that's eventually going to be a problem. But WebAssembly isn't in there, but it's everywhere else. I haven't found any evidence to the contrary that it isn't in any browser that anybody's using other than Internet Explorer. Okay? So what it is a virtual machine that loads binary files, just like you would run Windows files on Windows. There's a format, like there's an executable, compilable format. The extension is .wasm. All right, where we have .exe in Windows, right? It's .wasm. And so those languages can be compiled to those WASM files and then run in this virtual machine. The thing is that WebAssembly lives in the same kind of security sandbox that JavaScript lives in. So if you can't do it in JavaScript, you can't do it in WebAssembly. And I don't mean just Blazor, I mean WebAssembly. So WebAssembly is this black box that runs code with the same security clearance as JavaScript, but other languages can compile for it in binary. So everybody's really excited about this. Apple's very excited about it, right? You've got C++, you've got Golang, you've got Rust and Python, and I think Apple might even have some of their languages for it, but I'm not sure about that. I don't live in that world. Somebody can correct me. So it's very exciting, and it isn't going away. And now let's compare it to Silverlight and how Silverlight went away. I sometimes hear Microsoft screwed me by killing Silverlight, and I don't trust them. All right, well, trust WebAssembly. All right, because WebAssembly is here to stay. This isn't a Microsoft thing. WebAssembly is not a Microsoft technology. What is a Microsoft technology is .NET. And .NET has open sourced itself and runs cross-platform. And so there's a .NET CLR that runs on top of WebAssembly in the browser and supports .NET Standard 2 compatible assemblies. So it's that simple. They made a CLR for WASM, and then everything else gets loaded on top of that. So let's talk about what Silverlight was. Silverlight was a plugin, okay? Like Flash was a plugin, and I say was because most browsers don't allow plugins anymore. Why? Why don't they? Well, it started with Steve Jobs, yes, but the browsers quickly followed suit by taking plugins support out of their browsers. The big problem for Steve Jobs, there was two problems. One of them was that Flash was draining the batteries of his mobile devices, iPhones and iPads. People would watch a movie and they get halfway through the movie, the battery would be dead. So it was a real CPU intensive CPU sucker, right? That was problem number one. Problem number two, which was the real problem that most other browser makers had, is that it was insecure. The plugin model, right? The plugin model is how browsers allow Flash and allowed Silverlight to instantiate themselves, all right? But it had security vulnerabilities that couldn't be fixed. And so basically Steve Jobs wrote this white paper that said, was called Thoughts on Flash. And in there he said, Flash is detrimental to our business model. We are therefore taking plugin support out of iOS browsers, Safari, and everybody sort of followed suit, at a certain time. So Microsoft didn't kill Silverlight. Steve Jobs took support for plugins, mostly because of Flash, out of iOS, and that sort of put a damper on the whole Silverlight project because most people who were developing for it were looking forward to a way to use C# to develop with XAML applications and deliver those with the browser. So that's the story. It's not as simple as, Microsoft killed Silverlight, and it's not as simple as a WebAssembly. Blazor is the new Silverlight. Okay, it's not. Blazor is actually so cool because unlike most languages that compile to WebAssembly, we've got a runtime, right? Yeah, we love our runtime. So the CLR is the magic that allows us to do .NET in the browser. So I hope I've settled the score there and we can move on. So it's interesting that this slide, and I thought it was going to update today, but there was a new preview that came out on the 16th. And Dan Roth, hopefully, will be here later to explain all the new stuff and to talk about that. But before that, I just want to tell you this is essentially what you do. Don't go to this URL. Search for Blazor WebAssembly Preview 4. Okay, because Preview 4 came out on April 16th. Code-wise, it's going to be exactly the same. There's no difference. There's just some updated features and things. That's all. So don't worry about, this not running. No, you can just go ahead and get the latest stuff. All my code is going to run just fine. You have to install the latest .NET Core SDK 3.1. You have to get the latest Visual Studio 2019 preview, but the Community Edition works just fine. The Community Edition is free. And then you have to install the Blazor WebAssembly template. And as I said, if you Google Bing Blazor WebAssembly Preview 4, you'll see Dan Roth's blog post where he announces everything, gives you a link, and shows you how to do all that stuff. All right, so it's very straight ahead. Now, if you want to make a Blazor server application, it's easy. Just any release version of Visual Studio 2019, any Visual Studio 2019 and .NET Core 3 will let you make a Blazor server application. Blazor WebAssembly is still in preview. In May, at the end of May, I believe, we're going to get a release to manufacturing, an RTM version, where all the plumbing will be baked. But again, I got to stress, the code, the model right now, the component model, syntactically, no problem. It's baked. It's solid, and it isn't going to change. So the code that you write for Blazor today is going to run when it ships. Release to manufacturing is in May, but it's going to ship with .NET 5 in November. Okay? So that's when .NET 5, the big one, that unifies cross-platform .NET Core and Windows components, is just going to be called .NET 5. All right? Hope that clears that one up for you. So let's talk about both of these hosting models and how they work. And specifically, I'm not just going to describe it to you. We'll peek behind the covers and look at the network traffic, and we'll see what's going on. And I'll explain exactly what's happening. So with the Blazor server model, and then this is all I'm going to say before we switch over to code, the secret sauce, the magic that makes it happen is SignalR. Okay? WebSockets, a long persistent connection between the browser and the server. And every client gets their own persistent connection. All right? Unlike HTTP, where when you click a button or navigate to a page, the browser opens a connection on port 80 and sends a HTTP request. The server gets that request, gets all the stuff that it needs together, and then sends it back and closes the connection. This socket connection stays open with SignalR. And so the server can push things to the client, and the client can push stuff up to the server, and it's a persistent connection. Comes with its own challenges. We'll talk about that. So let's move over to code, and I will show you, literally move over, and we're going to create a new Blazor application here in Visual Studio 2019. This is the preview version. Let me just get my screen a little bit better here. I'm going to call this Blazor server, and we'll get the right place to put it. There it is. So what I'm going to get here is a Blazor server application, which is a .ASP.NET Core 3.1 application. In fact, if you have an existing ASP.NET Core 3.1 application, or 3.0 even, you can add Blazor server to it just by adding the right middleware in the startup, and then you can add Razor pages. So here we go. If you take a look here, and yes, my Zoom it is working. You got a pages folder, and we've got inside there a few things. We've got this index, which is the main page, and we've got a counter page, which is a simple demo that shows a button, display interaction, and fetch data, which shows how to get some data from a server, or from a service, actually, not necessarily a server. So let's just run this guy. And I'll pull up the counter page while this is running. You can see that it is just a little HTML and some code and a few directives right there. And that's all there is to it. Where are you? There you are. So here we go. Here's our counter page, and I'm going to click the button, increment the counter. Ooh, boy, howdy. Isn't that fun? Well, they made it easy and simple because they wanted to show how simple an interaction can be. But take a look at this, and it's not so simple, actually, what's going on behind the hood, under the hood. Mixing my metaphor mixing. Redundancy department. So here we have a variable current count, which we're displaying with a one-way binding with the Razor syntax right there in a paragraph, or a paragraph element. We've got a button, and this @on click says that this is a Blazor server-side method that I want you to run, and it's called increment count. There it is. There we increment current count. Now what's really going on here is there's some SignalR magic happening. By the time your page is up and running, there's a SignalR long connection going on, persistent connection. And when you click the button, you can see that we have sent down to the browser when we started this JavaScript file right here, Blazor server JS. Okay? That goes down to the browser. Now, where are we here? When I click a button in the browser, that's because we're stopped here. When I click a button, that hooks the DOM and says, oh, this is a Blazor action. I'm going to send over SignalR a message to the server that says, hey, user, click this button. Right? And you can see we can hover over that and we get a breakpoint here. But it does look like magic. So then the server says, oh, well, we have to call the increment count method. It calls it, and it updates the browser. Well, how does it do that? Well, it knows that this @current count here, this current count that it just incremented, has changed. And it looks at the entire DOM. It has a graph of the DOM, the client's DOM, in memory. And it gets a diff, and it says, oh, well, that little element has changed, and this element has changed, and that element has changed, and maybe a whole bunch of changes, right? And then it takes those and it packs them up in a binary message and sends them back over SignalR to the browser, and the browser updates the DOM. So we can see this actually watching in real time. If we open up our F12 tools and we go to network, and I'm going to disable the cache, and I'll just press hit record here to start recording events. Then I'll press Control F5, and we'll see what we got. So Control F5 refreshes the whole browser, and everything gets resent. And you can see the current counter is now 0. So first of all, take a look at this. 164K. That's not a whole lot. I mean, I have JPEG files that are bigger than that, right? That I send over. Now, granted, it's just a counter. There isn't much there. All right. But let's look in this list here, and you see this curious little Blazor underscore Blazor ID equals blah blah blah, and it's a WebSocket type. So that means that's SignalR. So now if you click this, you can actually see the size of the messages and which direction they're going as they get sent. So also, look here. The first message is this protocol, Blazor Pack. That's the binary protocol that they came up with to send messages over SignalR. But I'm going to clear this, and I'll just click a button again, and then we'll go take a look at what just happened. So that first 291 byte message is me when I clicked it, that JavaScript hooked the DOM, and it sent a message over SignalR to the server, essentially saying the user clicked the button, right? So then the server ran increment count, and it did a diff of the DOM, and it figured out that that P element had to update, and it sent a binary message back to the browser, 148 bytes, that said, hey, update this element. The browser updated the element, sent back a yes, everything's working now, and an acknowledgement that everything is A-OK, and that's what you're seeing there. So very, very efficient in terms of how it all works together. I've got a couple of slides that show, well, one slide that I can blow up here, that just shows the server-side hosting model. That SignalR hub, by the way, isn't for you. That is for Blazor and Blazor only. If you want to add your own SignalR hubs to your application, knock yourself out, but you have to create your own hub and all that. Fortunately, in .NET Core, SignalR is already built in. You don't have to add any NuGet packages. You just add the hub. You add a couple of lines of in the middleware in your setup, startup CS, and you've got SignalR, and it just automatically runs and loads when the project loads. So that SignalR hub, as I said, is a one-to-one communication between the browser and every client. But that means that, you know, there's some resources that are allocated on the server in order to handle that. So let's talk about what those resources are. There's two, really. Memory, CPU, and WebSockets, right? So the more CPU you have, the more CPUs and the more powerful they are on your server, obviously the better off you are at being able to handle more clients. But memory also is a limitation, probably the primary limitation. And it's estimated that Blazor server requires an overhead of at least 85K per client. Now that's the bare minimum. When you start adding, you know, sending, binding lists of customer records that have 1 million items in the list, right? Now you're keeping 1 million items in a list for every concurrent client, right? That can turn into quite a bit. So you want to be judicious with your creation of, you know, per client memory and how you use that. But that doesn't mean that you doesn't mean that you can't use lists of things, but be smart about it. Allow them to filter and search. And if you're using third-party tools like grids, use paging, so you're only seeing one page at a time. I mean, if you've been doing web development all along, you're probably already conscious of the ways that you can conserve memory. But, you know, 85K just as a baseline is pretty small. And I'll give you some real numbers from a test that Microsoft did in just a minute. So WebSockets are the other limitation, the other scarce resource. And there's a limit, but it's based on memory and CPU. Again, it comes back to memory, right? So if you want to completely scale out, scale SignalR, removing it from your server, you can use Azure SignalR service. And this is a link that shows you how to create an Azure SignalR service resource and then get the connection string and connect it up in your Blazor application, and poof, Now you don't have SignalR in your Blazor application. It's outside. All right. So scaling means two things, right? As you probably know. You can scale up, which means adding more memory, more CPU, or you can scale out, or both. You can also scale out, which means adding multiple machines. All right, now, if you think about it, when we looked at this guy right here, current count is part of the state of this page. All right, and if you're on multiple machines, let's say you have a Kubernetes cluster or something, every time the user clicks a button or whatever, they could go to a different machine. And first of all, you're going to need to get SignalR out of that machine with the Azure SignalR service. But next, you have to worry about state. You have to manage that state. It has to go somewhere besides in that machine's memory. So we're going to talk about that in coming up here. Because state management is key to scaling out. All right, so this, as I was promising before, are some numbers that Microsoft did when they tested Blazor. They tested for, and Blazor Server, they tested for appropriate latency. Now, if you think about it, there's going to be latency because when you click that button, you have the added hop to SignalR, right, just for the UI. And then things happen on the server, and you have that round trip going on. Whereas if you just had some JavaScript or some WebAssembly code to click and increment a counter, you wouldn't have that latency. So what they did is they built this reference application, and it was a real application. It wasn't a counter button, but they automated it with clicks, and they did 1 click per second, and they continuously added clients and concurrent connections until the latency got to be 200 milliseconds or higher. And it turns out that with one virtual CPU, meaning with a server with one virtual CPU and 3.5 gigs of RAM, they could comfortably handle 5,000 concurrent connections. Now that means people who are actively using the site, even if they're not clicking, all right? If they're connected to that SignalR connection, or the circuit is closed, as they say, then that's a concurrent connection. All right. So 5,000 comfortably with 3.5 gigs of RAM on a server. If they boosted that up to 14 gigs of RAM and 4 virtual CPUs, they got 20,000 comfortably. So you could have 20,000 concurrent clients using your application comfortably, getting less than 200 milliseconds of latency for every UI interaction. Yeah, so that's without Azure SignalR service. That's one server. Okay, so think about it. If you can scale up, scale up. You don't have the complexity of scaling out, but it all depends on how many concurrent clients you want. All right, so this should be a good guide for you as to approximately how many you can support. So we'll talk about the benefits and the downsides to this hosting model, the server hosting model. And then we'll go into WebAssembly and we'll do the same sort of experiments, okay? So the benefits of using Blazor Server, download size is significantly smaller than a Blazor WebAssembly application, and the app loads faster. You saw, well, I don't know if you saw, we didn't really compare how fast it loaded, but it loaded pretty fast, loaded pretty quickly. And 164K is all that got sent to the browser. That's not a whole lot. All right. And because the state is on the server and it doesn't have to be persisted with the browser, then you don't have that sort of view state problem that web forms has, just to, handle the state of the UI. We can handle that in different ways, and I'll talk about that in a minute. So you're on the server, and there's many benefits to that. When your code runs on the server, first of all, you can access whatever resources, secret code, anything that you want. If you're already used to MVC, programming, you know this. You don't have to build an API layer, a web API layer, in order to do basic UI stuff, or in order to call into a database, right? Because your code is already on the server, you can just call into your data access layer. Your secrets are in your config file. Nobody's ever going to see them. You can call cloud services that have keys and security tokens and all that kind of stuff. It's easier and takes less time to build the app because you don't have that added API layer that's required if you're doing a WebAssembly application to access resources that require secrets. Also, every browser is supported. Even Internet Explorer 11 will run a Blazor server application, given that there's a polyfill for it that you have to install, but that's easy to do. And this is important for some people. The code, since it's on the server, nobody can look at it. Nobody can decompile it and see what you're doing. Okay, now that's not really an issue to me, but I put it in here because some people are concerned about it with WebAssembly, not with Blazor server. But if you think about it, you have the same problem with JavaScript. And you can only come to the conclusion that you should not write code that has either secret algorithms or accesses your databases or anything like that, or has any passwords or anything like that in it on the client. Client code is for UI and UI only, right? All of the stuff that requires those secrets should be on the server. And if it's JavaScript, you do it in Node, right? No different. So I think it's a moot point, but I put it on there because some people have that question about, are you worried that people can see your code in WebAssembly? No, I'm not. All right, on the downside, you add the added latency. The added latency of having to go through SignalR, right? That means if you have a slow network connection, when you click a button, you can't instantly update and say something like, please wait, unless you actually call JavaScript to do that, right? Before you get any kind of UI interaction or response, you have to go to the server and back. So if the connection is slow, that'll take longer. And if the connection dies, your app stops working. There's no offline support at all. So yeah, that's a downside, and you have to consider that. Now, what that means is that think about the application that you're going to write. Who is it for? Is it for clients where you think they're not going to be in some bunker somewhere on their phone where there's scattered Wi-Fi or whatever? Hang on one second. I want to... All right, give me 1 second. If you're behind a firewall, or if you're doing business to business or business to consumer kind of stuff, yeah, that's obviously perfectly reasonable to do a Blazor server application. If you know that the client has a good internet connection, that's a good candidate for a Blazor server application. All right, so are there any questions that haven't been answered on this model before we move on to WebAssembly? I'll just give you a few minutes to ask questions, and I will check out the chat room here in just a second. It looks like Don's been doing a great job of answering questions. Thank you, Don. And it looks like you're all good to go. All right, so let's move on. Okay, so the Blazor client hosting model is obviously pretty easy compared to the server one. The WebAssembly loads in the browser, and then all of the CLR is downloaded, and then all the assemblies in your project run on top of that. So it's fairly easy to understand compared to, there isn't the magic of SignalR there, but it has its own challenges. So let's talk about those right now. But first, I want to say hi to Dan Roth. He's over in the chat room. Let's make sure we can hear him. Dan, can you hear me?
Hello. Yes, I can hear you just fine.
All right, good. We're going to get back to you toward the end of the desk show, but I just wanted to make sure that you're there and everything works, and good to see you.
All right.
All right, we'll come back to you. Thanks. All right. So the client hosting model is quite different, as I said before, but what we're going to do is watch the traffic just like we did before with the Blazor server model. Let's open up, let's actually add a new project to this solution. It'll be a Blazor application. We're going to call this Blazor WASM. WASM is the extension for WebAssembly. Oh, and here's a documented feature of this version of, undocumented feature of Visual Studio. You notice my WebAssembly template went away, but here's the workaround. Just go to .NET Core 3.0 and then 3.1, and it comes back magically. Okay, so notice these two options right here for a WebAssembly application. ASP.NET Core Hosted and Progressive Web App. So if I check Progressive Web Application, then we're going to get all the basic files that we need to support PWAs, a manifest, a service worker, and the bare minimum required to actually install it to your home screen if you access it from a browser, on a phone, or on a desktop machine. Okay, but this one right here is really interesting, ASP.NET Core Hosted. And I'm going to check that one off. If I don't check that off, I just get a client application that when I run it, it goes to the browser and everything's cool. But if I check that off, I can have it hosted from this ASP.NET Core 3.1 web server. And it even puts an API controller in there, right, for the weather forecast, which is the weather forecast service is sort of the default service that the Blazor template uses to show how to get data. But we also get this shared project where the models go. So this is a good idea, just architecturally, to have a server that hosts it so that you have a place for controllers without having to use cores, cross-origin. And you can also have this shared place where models go so that the client can also access them. And here you go. Blazor WASM client's going to run in the browser. Blazor WASM server is going to host the client, right? Like another web page, if you think about it that way. And it also has a place for controllers and things like that. So what I'm going to do is set Blazor WASM server to the startup project and run that. And we'll do the same thing that we did before. We're going to watch watch the traffic with the browser tools. We'll open the network tab, and we'll see what's going on. Takes a little bit longer to load up, and you'll understand why in just a minute. So I'm pressing F12 here. I got my network tab open. Here I'll disable the cache, and I'm going to start recording events. I'll press Control F5 to completely refresh. And yeah, here's what we get. Okay. 17.4 megs came down, but it compressed to 6.3 megs. All right, first of all, before I tell you the story here, is 6.3 megs a lot? It's more than I want. But if you consider Gmail gives you 5 some odd megabytes of JavaScript, and an Angular application is going to give you 5 or 6 megabytes or whatever, it's not so bad. However, 6 megabytes is the maximum for baseline stuff for Blazor. Here's why. In debug mode, in this preview 3, the linker is turned off by default in debug mode. Now, when the linker is on, you're only going to get those parts of the .NET framework, the base class library, which you're actually using. Okay? So most of the time you want the linker on, but they turned it off in this preview in debug mode. So just to show you the difference, we're going to set this to release mode. And we'll run it again and see, how much with the linker on. Now you can turn the linker on with configuration too, but this is just an easy way to do it for a demo. Oh, yeah, there it is. Okay, F12, one more time. Network, disable the cache, start recording events, hit Control F5. Okay, now 2 megs. Yeah, that's better. But okay, we didn't really do anything. So yeah, even though the linker's on, we're not really calling anything here in our code. So minimum 2, maximum 6.5 or whatever it is, baseline. Okay, but check this out. If I go to counter, notice there's no code, there's no traffic. And if I start clicking, there's no traffic. Why? Because it's running in the browser. That's why. Look at all the code that's running in the browser. Let's sort by size, descending, and you can see right here, .NET WASM is the biggest file that got downloaded, and that's 774K. Guess what that is? That's your CLR. That's your mono version of the common language runtime. And then here are the base class library files, and then you have other assemblies and JavaScript and yada yada. All right. So that should really drive home to you the difference between these two hosting models. In fact, the code looks exactly the same. Okay, it's not exactly the same. There are some differences architecturally, and you'll see it and figure out why that is. It should be obvious when we start looking at the code. But let's look at the benefits and drawbacks of this hosting model, the Blazor client or Blazor WebAssembly hosting model. First of all, you don't have that extra hop, so you can take away the latency that's required, that happens because of that signal R hop. You have offline support. Because you can make a progressive web application, you can cache data and load it from the cache without having to change your code. That's what a PWA is really good at. And that's all done in the service worker. Because it doesn't require a server to run, you can package it up and distribute it with a CDN. Okay? And as I said before, any .NET Standard 2.0 C# code will run in the browser. All really great benefits. The downsides. Blazor client can't access not just your database, but any code that is either sensitive, requires secrets, or isn't something that you want, an algorithm or something that you don't want the client to see. But look, it's the same with JavaScript, right? But the long and short of it is, if you're going to build a real application in Blazor and you're trying to think about these models, you have to add in the time required to build a proper API and the services to call it, right? So that can make you less productive, but it's a requirement if you're going to, use the WebAssembly. Okay. Debugging in Visual Studio still isn't complete, and even with the version that came out on the 16th, Preview 4, there's still all the things that you're used to doing in the debugger aren't there. Some things are, breakpoints are there, stepping through some things. Inspecting arrays, you can't do that. You can't step through manage code. There's a list of them, and they're up there on the preview page when you install Blazor WebAssembly, the template. As I said before, the schedule, it will be, I believe the RTM is in May, at the end of May, and then in November, it will be shipped as part of .NET 5. So again, I have to mention this, people can disassemble your assemblies. You can obfuscate them, of course. That is like minifying JavaScript. But the reality is, don't put sensitive code in Blazor C#. Just don't do it. Run it on the server. It's easy to do. You make an API. All right, so any questions on this, on Blazor WebAssembly? And again, it looks like Don has got the questions covered, so I guess I don't need to look at those. Good stuff. All right, let's talk binding. Oh, binding is wonderful in Blazor. I'm so happy that that these guys took the time to simplify the component model, where binding is concerned, where events are concerned, event handling. It's really, really elegant, and there's so much less ceremony required than, say, with Angular or even WPF, right? The binding is just beautifully, beautifully simple. So rather than read this slide to you with code on it, let's actually go back to our project, and we'll make Blazor Server the startup project. I'll go back to debug mode, and we'll open up index. This is your startup page, and we're going to hijack the index page so that we can show some binding stuff. So I've got some snippets here. All right, this essentially is going to, and I guess I can just pull it up while I show you the code at the same time. We have a message here, a message string property, two-way bound message. We're showing that. You've already seen one-way binding in the counter page, right? Essentially, we have in a span or an element some text that or some property value that we want to show. But two-way binding means that we can accept it as input as well. And so the input element, we can use the @bind without a specific property that we're going to bind it to, because the default property of the input element is value, which is the value of the text inside the box, right? So we're binding that to message. Now what happens is there's an event that occurs in the DOM that forces this update. It forces what's in the text to, it forces the message to be set to what's in the text. And by default, that is on change. And it happens whenever you lose focus on your element. So here I'll update it. And now I'm going to hit tab, so I force a loss of focus. That causes the change on change event to occur, and that is the event that makes the binding stick, if you will. But I can also change that event, and I do that with bind @bind::event equals, and let's change it to on input, which means every key press will update message. So we're essentially changing the event that forces the binding update. And now on every key press. And one thing to keep in mind is that every key press, all right, we're hooking and sending up to through signal R to the server, hey, the user pressed a key, all right, updating the binding, updating that element in the DOM, and all of that is happening on every key press. Okay, so just keep that in mind. I mean, it's very responsive and it works really well. But there you go. Now, one other thing I want to mention is that the default event is value, but if you want to be explicit with the property that you bind to, you can specify it with a dash. So if I say bind dash value right here, it's more explicit that I'm binding to the value property. Oh, and by the way, I have to, if I do it for bind, I have to do it for bind event too. So there you go. This is going to do the same exact thing, but we're being more explicit here as to which property we're binding to on that control. Okay? So now we're going to create a component, and everything about Blazor is components. A page is a component with a page directive. But it is essentially a component. And the component model, well, I'll show you what the component model looks like. You know, we can actually look at it, the base class here. Let's add to our shared folder a Razor component, and I'm going to call this child component. Here's another undocumented feature of this Visual Studio Preview. If this happens, you just close the file and reopen it. Okay? So here's a child component, and notice it doesn't have a page directive because it's not a page, it's a component. So here's what I want here. I want some UI, a div, that has a little bit of inline styling here, padding, and a background color of light gray so that we can actually tell when we look at it that it is the component. And we have a one-way binding here of parent message, which is a string property. And then a button that calls update message. Let's look at that. So notice private async. Yes, any handler, any event, any method can turn from void to async just by making it async task. There's nothing else that is required there. So if you're going to call await, make sure you have async task or async whatever if you're returning something. So here we're updating parent message to Blazor, and then we're calling an event. Yes, we're defining an event. So first of all, parameters. Both of these are parameters. Parameters mean they can be accessed from the parent. All right, that these are values that come in and values that can be bound to on the output. So think of them like public properties in a custom control. Okay? And even though they are public, if we're going to access them from as parameters from the parent that instantiates them, that's what we have to have parameters. So look at this elegance here. This is how we define an event. Event callback, and then whatever we're going to pass through that event. We're calling it message change, and here's how we invoke it. Message changed, invoke async, parent message. Right? We didn't have to create an event handler. We don't have to have a custom event args. None of that. Like, it's just very, very simple. And I love that. So let's instantiate this now. Here it is right there. The only thing that I've added here is this child component. And this is how we instantiate a component. Child component. Now we don't have an event handler for message change per se, but we're doing it all with binding. Check this out. We're saying I want to bind this control's parent message property to my message property. All right? We're being explicit, just like we were up here with bind value. Now we're also saying that we want the event that's going to cause this change to occur to be message changed. Child component message change. So when the component raises message changed, my message is going to change. And I know I'm changing all over the place, but I hope you get it. So here we go. Update on key press even to component. Right? This is inside the component. This is the one-way binding in the parent. This is the one-way binding in the component. Now we're going to change it from inside the component, and poof. Just works. Look. Observe. Observe how elegant, how wonderful, how easy. Right? Do this in Angular. It's not that easy. Right? Just to get set up, it's not easy. This is just, I love the way Microsoft has simplified programming. I want all my programming to be like this. I want WPF to be like this. Right? I want Windows Forms to be like this. This is beautiful. All right, enough of that. I'm really happy about it. So now let's talk about state. As I said before, scaling up a Blazor server application is, you throw memory and throw CPU at it and move SignalR out to Azure SignalR service. But if you're going to scale out, and let's be honest here, we're talking about scaling out a server application. A client application doesn't need to scale out. It's one browser, okay? You may still want to manage state. You may want to get things out of the page. You may want to store them somewhere so that when they come back to the browser, everything's still there, but it's all on the browser. You can use local storage for that. It's quite easy. But let's talk about state on the server. So the big issue here is, first we have to get rid of the state that's in our pages if we're going to be able to load and save it and manage it. And if we want it to exist outside that page, every single time you navigate to a page, it gets reinitialized, right? It gets all of those page level variables go away. So let's see what this is like with counter. The counter page has this current count right here, right? And every time I navigate to the counter page, everything gets initialized. All the life cycle methods get called, and everything resets. So here I'll show you. I'm setting the counter to 6. I'll go fetch some data, and then I'll go back to home, and then I'll go to the counter, and it's 0 because the initialization happened and everything got wiped out. So basically what I'm saying is, if you don't care that these values here, these variables get wiped out on initialization, go ahead and do it. But let's say you want them to exist on no matter what page they go to. Well, now we can move the values of these state methods, members, classes, objects, whatever you want to call them. We can move those to a service, to another class, and then scope that class so that it either exists in a singleton or as a scoped service, which means that, well, I'm getting ahead of myself. Let's move it to a class, all right? So here I'm going to add a class called appState. And if you're going to scale out, this is definitely the first thing that you need to do. Move all your stuff to a class. So this is going to have a public int called counter. And this is what we're going to use instead of that the counter's current count. All right, but how do we get that there? Well, we could just instantiate it here, but if I instantiate it, it goes away every time the page loads. So I want to move it into a scoped service. So let me write the code here first, and then I'll explain it. So I'm going to add scoped and appState instance, and there we go. So what a singleton is, now this is on server, is that every client shares one instance of that object, the weather forecast service object. And why not? Because it's just returning some random data. There's no need for everybody to have their own instance. But that's what scope does. It gives every client their own instance of this appState object. And that's exactly what we want. This is reminiscent of the session object, right? A scoped service is kind of like a session object. It's going to be available to every client. Every client can load and save stuff in there, and that's going to exist on any page you want, any page you inject it into, all right, for the life of the session, for lack of a better word. So let's go to counter now, and we'll inject it. We'll use that @inject. The type is appState, and the variable name will be appState. So this does not instantiate, all right? This injects an instance, however it's been scoped. If it's a scoped instance, then we get the same instance in every page that we inject it into, one instance. If it's a singleton, everybody shares it. This would not be good as a singleton, right? for obvious reasons. All right, so we're going to get rid of current count. And now we're going to use app_state.counter. We'll use it here. We'll use it here. And yes, it's just a simple example, but it drives home the point that scoped services are a place where you can store things that you want to exist between page initializations and for the life of your clients accessing this page. Okay? So that's step one. Well, what's step two if we're going to scale out? Persistence. Now, where to persist? That's the golden question. Look, we could use local storage, and I'm talking about server here. Local storage with client, no problem. That's a good solution. That's a place in the browser that has a secure name value store where you can load and save dehydrated objects, all right? JSON versions of code, objects. And you can load those back up again, no problem. But on a server, it's going to be more like the view state story if you do that. It's fine for a few things, right? Maybe a few K worth of data, put that in local storage. And in fact, I even have a shopping cart blog post where I make a shopping cart and put it into local storage, and totally ripped off the idea from Steve Sanderson. He showed how to do this. He showed how to do it with counter. I just turned it into, a shopping cart object. So you can go to that blog post, you can download the code. It has all the stuff for local storage. It's pretty easy. So that's good on server for maybe a few K worth of data. But any more than that, because here's why it's not a good idea to store all the stuff there on Blazor server, is because to read it, right, I have to send a message down to SignalR. It's going to read from local storage. It's going to send it back to the server. Now I've got the data on the server. Now I have to put it into my controls, whatever lists of things, whatever, bind it. And now it all goes back down to the client again over SignalR. So it's like view state. It gets passed along, right? It's not good for a lot of data. It'll slow things down. So really we're talking about server-based persistence, databases. What kind of databases? Well, I'll tell you what you don't want. You don't want relational databases like SQL Server. Not only are they more expensive than a document database, which is what I recommend, but they're unnecessary. You don't need the relational stuff, and expensive too. Cosmos DB, okay, the latency is great, but you pay for it, and it's probably the most expensive option on Azure. So think about MongoDB, think about RavenDB, think about document databases, document DB, right? Think about place where, like a name value store, where I can just pass a user ID, a GUID that represents the user, and then pull back all the state that I want. And maybe I want to do it just a little piece at a time. But the idea is that that's what you do. And when the page initializes, you go get the state, and then you hydrate it up. And as they make changes, you're saving it, you're saving it, you're saving it. So that way, when a new button click comes in and your Azure SignalR service handles it, and Blazor gets the message, right? Now you can go get the state, and you have a seamless experience for the user. And that is how you scale out Blazor server. Woo! Okay, well that hour just flew by. Now I want to show you perhaps the coolest thing about the Blazor Desk show, I think, which is you can develop both a Blazor WebAssembly and a Blazor server application at the same time in the same solution. This solution that I have right here does have a Blazor server application and a Blazor WebAssembly application. right? But right now we have two code bases. So what we really want is one code base, but to run in two different environments. And why do we even want to do this, by the way? Why? Is this just a parlor trick, Carl? Well, it might seem that way, but no, it's not. In addition to getting now what this is, first of all, is just to be clear, we're going to use the client-side code base, right? The markup in the code that's in the Blazor WASM client. And we're going to access that and run that from the server. So the server guy is going to create a reference to the client, and we're going to use that markup, but run it on the server. The client's going to run just like it is, and then we can run both of them at the same time. All right? So why would you want to do this? First of all, you get the full debugging experience if you start the interaction from the server, okay? Even though it's in the client project. Secondly, and that's only going to be relevant until the debugging is fully baked, which is going to be pretty soon, I guess. But secondly, you can punt the idea or the decision, you can punt the decision of which hosting model you want to build your application with until it's complete. And you can actually test it, right? You can build both hosting models at the same time. And then when they're done, you can test them independent of each other and say, yeah, we're going with WebAssembly or we're going with Blazor Server. You may want both. And here's what I mean by that. You may want to have WebAssembly be your first choice. And you can do a check to see if the browser supports WebAssembly. And if it doesn't, you can reroute them to your server application. Right? So you can do it both ways. But the idea is that you don't have to decide before you start coding. You can go all the way to building a testable application, test them both, and then decide which one you want to go with. I think this is really brilliant. And Steve Sanderson showed this at NDC London in January, and it was just like blew my mind. So let's do it. Let's do it right now with this application that we have. First step is to go to Blazor Server and add a project reference to both Blazor WASM Client and Blazor WASM Shared. All right. Remember, there's 3 projects in our client side. This is the server that hosts the client, but the client is where the code and markup is. And the shared is where the models are, so we're going to need access to both of those. All right, now here's the magic, kids. I'm going to go to the server app, Blazor Server, and to a file called host.cshtml. So yeah, this is where the header is. This is the body, your HTML skeleton, if you will. So your style sheets are here. There's the JavaScript framework, the Blazor Server JavaScript to hook the DOM and all that stuff. Then you have this div that has error messages for unhandled errors. This right here, that is all that's left. This is app. In fact, within the app tag, you have this little class right here, and that little guy, those three letters represent all of your UI markup and code. All of it. Not the JavaScript, not the services that are loaded in the environment, but the markup in the code. So if I change this to Blazor WASM.client.app, now when I run the server application, it's going to load the code from the client application, but run it on the server. Okay? So next, let's go to the solution properties so that we can run both of these side by side at the same time. We're going to go to multiple startup projects, and I'm going to start Blazor Server and Blazor WASM Server. So when I press F5, both of these projects are going to run, and we're going to get 2 browsers. Two browsers. All right, so I'll build the solution. Looks good, looks good. I'm just checking the chat room, see if there's any disgruntled people there, and no, it looks like you're all perfectly gruntled. All right, so let's separate these out here so we can see the difference. Now they both say Blazor WASM right at the top of the nav bar, but that's because that comes from the code in markup. But what doesn't, what comes from the HTML that kicks it off is this right there, the title. And it's Blazor server over here and Blazor WASM over here. You can see they both have different ports. This is 44315. This is 44347. However, on the server side, where did my binding code go? Well, it's not there because this is the code base from the client, but it's running on the server. And look at this. It's the same code and markup running in a different environment. That's cool, huh? And of course, this works just fine as you would expect. But what do you think's going to happen when we click fetch data? Well, you probably don't know because I haven't given you any clues, but it's going to blow up. Now, because we're running in debug mode, we get an error that says see browser dev tools for details. If we were running in release mode, it would be not as geeky. You know, it wouldn't say press F12 customer and tell us what we did wrong. It would just say you may need to reload or something like that. Interestingly, when you get an unhandled exception, everything stops. I'm clicking on these things, nothing works. Okay? It stops working. And this is by design because your application is in a broken state. It's in a state where who knows what, you know, we don't know what the state of that application is. And if we allowed code to run, and then we might be able to, you know, use it as an attack vector. For example, or just do things that you don't want. For example, let's say you're ordering a $5,000 piece of equipment or something like that. You added it to the cart, your code charged your credit card, and then just on display, something went wrong. And so if we just ignored that and said, yeah, here's an error that happened, and allowed your code to continue, a guy would press it again and go through the whole thing again and be charged another $5,000. See what I mean? So it's good that this happens. It's a good thing. It's for your protection. But anyway, let me tell you what I mean, if we actually looked at the errors, you would have seen a lot of errors. But the first one would be this. It doesn't understand that there's no HTTP client. So in order to unravel that, let's go to the server code, which we weren't running, and show you what the weather forecast, you know, the fetch data looks like. All right. We have this weather forecast service, which is in Blazor server data over here. It's just a class. And remember when we looked at startup, this is added as a singleton, this class, right? So what we're doing here is injecting it so we can access it. It's a singleton. And we just say forecast service, get forecast async. It's all very clean because it's on the server. No problem. Now, what we did run here on the server was this version, which uses an HTTP client to call the API. Get JSON async. Weather forecast is what it returns, an array of those. Here's the URL. It's a relative URL. That's problem number 2. Problem number 1 is it doesn't have an HTTP client. We didn't have that service, right? And that isn't a code issue. That's an environment issue, right? So that has to be solved here in startup. And the name of the game when you're doing this is both environments have to have access to the same resources if the code is going to work. So services, JavaScript is something that runs in each environment that isn't in the markup in code. So let's add that. Services.add singleton or add scoped, it doesn't matter. HTTP system, come on now. System net HTTP, HTTP client. And now we can, just like we did before, we're injecting that HTTP client. And now I can call this. However, I need to resolve this URL. We can get away with it on the client because it's in the same app, right? We're hosting the client app with this server. So weather forecast controller, of course, it's on my server. It's in my URL where I came from. But that's not the case here. How do we find out? Properties, launch settings, JSON, not of the client, but of the Blazor WASM server. If I go to launch settings, JSON, under properties, in Blazor WASM server, I can get the SSL port because it's all localhost, right? But I need that SSL port to get the actual URL. So this is going to become HTTPS localhost colon my SSL port and the weather forecast. And now everything should work. So again, the moral of the story here is that when you're developing with this pattern, both environments have to have access to the same stuff. And yes, that means you are going to have to build an API, even if you end up going with the server-side option. If you're using this model to build, you're going to have to use an API layer. Okay? So it's the lowest common denominator issue. All right. Now I'm going to show you an application that I built. It's a smaller version, a more manageable version of an application that I built for my band. And it's called Band Booker. And the idea behind Band Booker is that rather than trying to get a 10-piece band to say yes to a gig by email, which is what I used to do, I built this application so that they could get notified when there was a potential gig, go into the app and then say yes or no, so we have a record of it. Otherwise, I'm creating spreadsheets. When it's gig time, who's playing sax? Oh, I don't know. I have to go through my email, right? It was kind of a nightmare. So the irony of ironies is I built this big application and on Blazor, and I brought it to the guys, and they were like, nah, we'll just use email. They're like, nope. But I have a good application. It's a good reference application. And the one that I do in my 2.5-hour Blazor workshop, which is actually turning into a whole bunch of, it's actually going to all be given away for free. So ignore that. Essentially what I'm going to do over the month of May is come out with a series of small YouTube videos that's going to combine the basics of what I'm talking about today with applications that I build, including Band Booker, that have authentication, authorization, SignalR, data access, all of that stuff in it. So, and even, rudimentary CSS for non-web developers. So it's going to be like this whole series of videos on YouTube, small topics, and that's what I'm doing for the whole month of May and probably beyond that. But anyway, the big application has, entity framework, data access. This one doesn't. It's just all in memory. The big application has 5 models. We only have 2. So it's just showing you how to do basic CRUD operations. But it also, this version that I'm going to show you today, has some techniques in it, like code behind. We're going to take code out of the Razor page and move it to a class where you can access all of the great features of Visual Studio. Input validation, which is really important. And this, I'm going to show you how to do that. I'm going to show you how to do JavaScript interop. Yes, we will call into JavaScript and make some calls. And I'm even going to show you some code where you can call C# from JavaScript. That's going to be cool. And also generic components. We built that child component, and it had a string in it. And the Band Booker application has components that are specific to each thing that we're going to edit, but there are also some pieces that we can genericize, and we can turn those into reusable components where the data is defined dynamically. The data types are defined dynamically. We're also going to cover authentication and authorization. Right out of the box, Blazor has support for identity, ASP.NET identity, authentication, and authorization. If you just check the box when you're creating a project. I'm doing this a little bit differently. I'm using JOT tokens and building API controllers to roll my own sort of identity, ASP.NET identity. Now, I'm not rolling my own security models and everything. I'm using ASP.NET identity with the database and the data context and all that stuff. But I'm not using the out-of-the-box UI and the out-of-the-box experience. I built my own register and login pages and built my own controllers for that. And also, we're using JOT tokens and storing them in local storage. So when you log in, the controller puts together a token that puts all your claims and your security information in there and gives you a token, which you can then store in local storage. And then when you run it again, pulls it out of local storage, logs you in automatically. So this is, it's a way to understand ASP.NET identity and make sure that you go through every aspect of what it is. So I got this code from Chris Sainty, who you should definitely check out his blog, chrissainty.com. He is an MVP like me. He also is seriously into Blazor, and he's done some, and continues to do some great blog posts about it. All right, let's look at Band Booker, and I'm just going to run it so that we can see what it looks like, give you the big picture, and then I'll point out the parts of it that, where we're using these techniques that I talked about. And yes, I actually did use the same technique of building both a client and a server hosted Blazor application at the same time. So this one over here is the WASM one. It is not logged in, and therefore I can't do anything. Over here, I'm logged in as one of the instruments. I'm sorry, one of the instruments is one of the musicians. Hairy chap. And now I can do CRUD operations on instruments and on musicians. So there's a lot of enabling and disabling of UI here. And you can see that the edit and delete buttons are disabled, but new is not. Okay. When I click new or edit, and I get this is a component that's specific to instrument. It's called instrument editor. Also, now notice that the select here, the list box, is disabled because I don't want people clicking and selecting another instrument while I'm editing one, right? So also notice that we have focus here, and you can't see it because now I've clicked on other things, but if I click new, now you can see that this box has focus. Well, in Blazor right now, in the component model, there isn't a way to set focus. They haven't surfaced that to the component model yet, but maybe they will, maybe they won't, but I don't know. But now I use JavaScript interop to do that. So this is an input control, and it has an ID, and I wrote a JavaScript function to get the element reference and set focus. Now, in addition to setting focus, it also selects. So if I do an edit, not only does it have focus, but select is on. So if I just start typing, let me type a lot of stuff, and I'll show you what happens here. Name is too long, and I realize that bright red on gray is probably not the best color scheme, but anyway, name is too long. There's validation built in, and it's saying that, the name of this control is too long. 50 characters is the limit. Now, if I clear it and try to update, I'm going to get the name field is required. So I have another rule in there that name is a required field. So anyway, I can cancel here, no problem. Deleting is just just what you think it is deleting. So that's instruments. Very simple. I create a new instrument. I name it. Hit enter. There it is. Now musicians are a little bit different. Let's pick Piano Patty here, and we'll edit Piano Patty. So I still have a name field here, but I also have instruments that Piano Patty plays. Well, guess which one it is. Double click. Now keyboards is in the selected instruments list. This right here is a generic component that I wrote called Object Picker. And if you go to objectpicker.appvnext.com, you can read the blog post about it and download the code, but you can download this code anyway. So Object Picker essentially is generic component. You pass it a list of all items, which is a list of instrument objects, and selected instruments, which are the ones that the musician plays. And then you tell it the name of the item, which is instrument, and the plural of that, which is instruments. And you tell it what the property to display is, and then the value property of the instrument ID or the ID or whatever it is. Right? So that's how you can identify it. So all this is for is selecting. Now, of course, you've probably written this UI a million times before, right? You can go from one list to the other, all items, selected items, but only one at a time. I mean, it can only be in one place or the other, right? So there's some code to manage that. So now Piano Patty plays keyboards. I can add a new one here. Let's say Che, and Che plays conga, not guitar, conga. And Che actually is the percussionist in my band, and he does play conga. So there you go. Now that essentially is the application, along with, so we did JavaScript interop, right? We did a generic component. Code behind is the other thing. This whole page, all of the code for it exists in a class, this index page. So that's the code behind. And the other one was validation, which I showed you it working. So now let's jump into it. Let's just start with authorization. So authorization is once you've been logged in, you've been authenticated. Now what are we going to allow you to do? What are we going to allow you to see? Well, there's this authorized view component built into Blazor, all right, where you have under authorized a subcomponent. You put all the UI that you want the authorized user to see, and in not authorized, whatever you want them to see. If they haven't logged in, please register or log in to use this app. So authorized view is pretty simple way to do that. Now you can do it with code as well, but this is how we're doing it here. You can use roles, so you can allow particular roles, and if the user is in that role, then they can see it. You can separate them with a list of commas. It's pretty easy. And let's see. Yeah, let's go through this UI here. Instruments. This is how I do a list box. A select, right? And size equals 10. If the size is greater than 0, then it's, if it is 0, it's going to be a drop down. If it's greater than 0, it's going to be a list box looking thing. And I go with a @for each to put the options in here for each instrument and instruments, which is just a list of instrument objects. I'm doing some logic to see if this is the selected instrument, right? If the ID matches the selected instrument, which gets set whenever I click on one, which happens here, instrument selected. And if it is, I'm specifying the selected attribute on the option. Otherwise, I'm not. And otherwise, these two things are the same. We're setting the value to the ID, and it's a string, right? So a string property, toString, and then instrument name. Now I have some buttons. New instrument button click is what happens when I click the new button. Now I have an edit and delete button, and we're setting the disabled attribute directly to a Boolean field, disable instrument edit button. So now I can turn that on and off and enable and disable. Same thing here, disable instrument list. I can just turn it on, turn it off just by changing that Boolean. So here we're instantiating an instrument editor component. And notice that I have this @ref right there. That's how I grab a reference to this instance. You know, I have to be able to call methods on it. I have to be able to refer to it, you know, get those parameters if I want to. And so I have a variable called instrument editor, you know, camel cased, which is an instrument editor object. And once I have that reference, now I can call the methods on it. So let's actually look at instrument editor. So I have a Boolean called show instrument panel. And this is just a Boolean, right? And if I set that to true, and I'm setting it here in new instrument and edit instrument, I'm setting show instrument panel to true, then the next time it's rendered, all that UI gets displayed. So this is where we're doing validation, and it all starts here with an edit form. If you're going to have fields that need to be validated, they have to go inside an edit form, because we need to control the submission. You can't just hit the submit button and have it do what it does until it passes validation. So it makes sense that the edit form is where we define that method, submit button pressed, not on the submit button itself. The data annotations validator means that we're pulling the validation rules from the models themselves. And let's look at, you see in Bandbook or WASM shared, now this is where models go. I have a models folder. Here's our instrument. Here's my ID, and you can see that the name has is required, and the length, the maximum length is 50, and name is too long. Is, you know, probably should be something like name should be 50 characters or less than 50 characters, right? And these come from system component model data annotations. That's where those are, and they're also that's just a NuGet package that you can download pretty easy. The validation summary is that those red messages that show, you know, name is too long or required field. There's also validation messages that you can put on each field if you want to do that. Now, input text is a what am I trying to say? It's a component that's built into Blazor that is essentially this, an input, but it has the validation stuff. So it's a subclassed input element that has validation aware code built into it. We've got the ID property here because we're going to use JavaScript interop to set focus to it, so we have to give it a name. And then the other thing I want to say about this form is I have another button, a cancel button, but I have to set the type to button, otherwise it will be considered a submit button. That wouldn't be good. All right, back in index, you can see I've got the musician stuff here and a musician editor, and there's no code. That's because the code is in a code behind right here. Now, this is index.razor.cs. So the idea is that you create a class in the same folder that has the name of the component or the page with a .cs after it. All components and pages have to start with a capital letter. True dat. So capital index.razor.cs. Then I have to make this a partial class. Otherwise, we're not going to know that this is part of the same component. We'd have to call it something else. And we're also deriving from component base. Now the other thing is that all of the pieces of this code that have to be reached or accessed by the markup have to be protected. At least. They could be public, but they have to at least be protected. So let's look at component base, because I want to just talk briefly about the life cycle of a component or a page. And so you can see that there's some really cool virtual methods here, and there are async versions of them. So on after render and on after render async happens last after the page has been rendered. On initialized happens first Actually, set parameters async happens before onInitialized. And then onParameters set happens next. And then finally on after render. OnParameters set, and I'm just telling you this, even though it's like do as I say, not as I do, because I got into the habit of putting my initialization code in onInitialized first. And so all my code is kind of built that way, and it works and it's fine, but onParameters set is probably where you should be doing your initialization. This happens just before the rendering, right? So go get your data, set up your SignalR connections, all the stuff that you would normally do in a page load in web forms. That's where you should do it on parameters set. The difference between these two in terms of the state of everything, it's kind of hard to tell. Like in my components here, let's look at instrument editor. These parameters here, like cancel pressed, instrument added, this instrument, those will be set in onInitialized, even though there's an onParameters set, which is where I'd expect them to be set. So they do get set there, but all of the parameters don't get set on onInitialized. I'm not sure which ones. Maybe you can ask Dan about that. But so that the moral of the story, though, is if you're going to override one of these things, it probably should be onParameters set. So this is where you should initialize stuff. Okay, enough of that. Let's talk about JavaScript interop. So instrument editor. This instrument ID name. So how are we going to do this? Take a look at new instrument and edit instrument. And first of all, if we're going to do any JavaScript interop, we need one of these. An IJS runtime. Inject it. I just called it JS for JavaScript. All right, you need one of those. So when I call new instrument or edit instrument, and I'm calling this from index, right? When the button gets pressed for new, we're actually we get the reference to the instrument editor, and we call new instrument on it. And here we're calling set focus after I've done everything, including show instrument panel. So where is set focus? That is in the place where JavaScript lives. Now it's in two places depending on the hosting model. In Band Booker, which is our server, and notice that I don't even have any counter pages or anything like that in there. It's in _host CS_HTML. That's where the JavaScript goes. That's where the JavaScript for Blazor is, and I just created my own script tag here and put that there. Now, but we're not using this code, right? Actually, we are. JavaScript is in the environment. I spoke too soon. On the client side, it's in www.root index.html, right there. Yes, JavaScript runs in the environment. It runs in the browser. So it isn't something that's shared within that app object. So I have to have it in both places. And it's exactly the same in both places. And hey, it doesn't have to be exactly the same. If you want the server-side version of a function to return something different than the client side, that's fine. But they both have to be, ooh, my arm went away. That's interesting. They both have to have the same signature, obviously. So look at all this Rube Goldberg-y stuff that I'm doing here. Why am I doing this? Well, I'll tell you why, but let me just first explain what I'm doing. When I call set focus, I am calling this internal focus method passing the ID, but only after 10 milliseconds. This set timeout says wait 10 milliseconds and then call internal focus passing the ID. 10 milliseconds later, we try to get the element reference, and it might be null. Why? Okay, glad you asked. We'll come back to that in just a second, but let's continue on with what it does. If the element is null, I'm going to call myself again in 10 milliseconds and exit. Okay? Little recursive thing. And I'm going to keep calling myself until I get an element reference, and then I'll call focus and select. Now, why would I get a null reference? This is a classic SPA problem. Okay, the problem is it's the that element doesn't exist yet problem. And at the time we call invoke to invoke that JavaScript method, this UI isn't in the DOM. It's only going to be in the DOM after it renders. Okay, all right, Carl, then why don't you just override on after render, right? Let's think about that. So if I go protected void override, and I'd have to do the async version, I know that. Protected override void on after render. Okay. What if I just call my JavaScript thing here? And of course, like I said, I'd have to make this async task and make this on after render async. But you get the idea. Why not do it there? Because then this will fire every time the page is rendered. When is that? A lot, right? Anytime there's an update to the page, it renders. I don't want to do that. Now I have to put logic in here to manage when it's safe to call get focus. That's a nightmare scenario. I don't want to do that. So it's much easier just to make the call here and to deal with it right here in this way. It's very simple. How long does it take? How many things are you putting on the stack? I don't know. It might take 100 milliseconds. It might take a half a second. I don't know. But it's still not a whole lot. And it all unwinds and everybody's happy. So that was my solution and my rationale for it. So far, nobody's challenged me on it, but that doesn't mean they won't. Social. Carl, that doesn't look like whiskey. Nope, it's Gatorade Zero. Yep, taking a break from that stuff for a while. But anyway. Okay, where was I? So we did code behind. We did validation. We did JavaScript interrupt. Generic components. Yes. I knew that there was something different here. Let's look at musician editor, Razor. So this is the one where we have the musician's name, and then we have the list of instruments, right? So our object picker, here's how we instantiate it. These are all the parameters. All items, all instruments. All instruments is a list of all the instruments. Selected items, musician instruments. That's the instruments that the musician plays. Excuse me. Item type and item type plural are just generic, are just strings that are used for the UI itself. This is all instruments. This is selected instruments. The text and value property names, right? Name for the text, that's what we display. ID is the value property. And that's it. That's all you have to do. And the object picker itself is a table. And the table has, you know, lists in one column, some buttons in another, and another list in the next column. This is what makes it work. At type param, T item. That is your generic item. That is your T, but we just called it T item. So that is going to be instrument in this case. Well, how do you know? Let's look at the code. In the parameters, it sort of gives it away. All right. All items is a list of T item. So this is how we're accepting that. And selected items is a list of T item. And the selected item itself, when we click on an item, that's a T item also. And so the UI does this thing in the list box. Remember the code that I had to check if the selected item had the same ID as this item? Well, this is what I'm doing here. I'm using item value and item text because I don't know the property names. I have to get those values. So what are we using? Reflection. Reflection, reflection, reflection. Yes, reflection. So this is essentially item text. Let's say you pass the item. It calls get type, get property on the property name, get value to string. So that gets the name property value. This gets the ID property value, both as strings. The rest of this here is all just this particular thing on parameter set, which remember is sort of like our onload. This is looking to remove duplicates because I'm passing all instruments and selected instruments, but the selected instruments are also in all instruments. So this is removing the ones that are selected. So I don't have to do that before I use it. Okay? And as far as authentication goes, this is where the code gets, we're doing a bit more here. I don't want to go into it too much, except I will show you the login controller. The login controller uses the sign-in manager, which is from ASP.NET Identity. That gets injected in here. And this basically signs in and gets the result. And if it was bad, then it returns back, a list of errors or whatever. Okay. Successful equals false if it didn't succeed. Otherwise, we create some claims. We get a symmetric key from the config. We basically create a new signing credentials and add that to a token with an expiration with the claims, and then we return this login result, which has the token in it. And whoops, wrong F. Come on, login result has the token, and then that is stored in local storage by the client and logged back in. And there's also an accounts controller that's used to register, and this has the user manager, not that for instead of the sign-in manager, and it creates a new user. All right. Deploying to Azure. If you're going to deploy a Blazor server application, you need to make sure that WebSockets is enabled on that particular server, app service. And if you're doing this from Visual Studio and creating an app service in Visual Studio will tell you, hey, you need to turn WebSockets on. You want to do that? Yes. Great. Visual Studio takes care of a host of problems. But if you have an app service that already exists, you have to go into the configuration for that app service and turn WebSockets on. Otherwise, your Blazor server application ain't going to work. Okay, I want to show you a few things about Developer Express controls. Because they're our sponsor here and because they can save so much time. They've been in the business of making developers productive, as I said, for a long, long time. Oh, and by the way, we're going to come back to this. This is preview 4 of Blazor WebAssembly. Dan Roth is standing by. I know you want to hear from him, and we will in just a minute. But I want to show you just a couple of things that I like about Dev Express controls. They have Blazor demos that you can, and the free Blazor controls. One of them is this scheduler. Look at this. This is just like dropping Google Calendar into your project. This is all drag and droppy stuff, and I can create new appointments, and I can move them around, and from day to day, and from whatever to whatever. Look at how much effort it requires to do what I just did in a Blazor application. Blazor client, Blazor server, it doesn't matter. Look at that. That's not a whole lot, right? A few lines of markup, some code to connect to our data source. Just really great stuff. Now, I asked them to create a band booker that did the CRUD operations, but using their controls, and see how little markup in code we could get it to use. And so this is what they came up with. So they're using a grid, 2 grid controls. Here's instruments and musicians, and this is CRUD stuff, right? So delete, yep, no problem. Create a new instrument, I'll call it conga, and I'll hit the update, and there it is. And I'll edit, and I'll change it to congas. And there it is. All right, so there's the CRUD operation on the instruments. For musicians, it's a little different, right? We'll edit piano patty, and we'll select the instruments, Now there's a drop down here, and I'll select keyboards, and that becomes one of Piano Patty's instruments. If I click again, keyboards is not in the list. Maybe Piano Patty plays bass too. There we go. So I can create a new musician, and I'll call him Che, and I'll select congas, and there it is. Right? So not a whole, it's CRUD operations. Yes, it's pretty simple looking, but it gets the job done. Now here's the best part. Here's the markup for instruments. Here's the markup for musicians. A little bit of extra because we have this edit form, but not a whole lot of markup. It's really pretty clean. And look at the code. Here's the code for instruments, just basic CRUD stuff. And here's the code for musicians. Right? Great. So the point here, I don't want to get into details about how this stuff works and all that, but suffice it to say is that you can be even more productive in Blazor when you use third-party tools like DevExpress. Interestingly, a list box, multi-select list boxes you can't do in Blazor just using a select. Here is a typical single select list box that I've created, and I'm holding down Control key and expecting to get multi-select, and it doesn't work. So this is just the basic select list box, and I just added a little bootstrap style there, form control. So this is the same kind of thing that you saw before. Now you might expect that I could just do multiple, which is legal in terms of the DOM for me to say multiple there, but it doesn't do anything any differently. Like change event args doesn't give me a list of items that were selected. It doesn't really work. And so that's just where we are right now. So I went looking on the internets, and I found somebody who wrote a multi-select list box control. And here's the form that uses it. And here's the select multiple, which is the component, and some stuff here. This is how, remember over here you saw I'm just going through the selected book, right? One selected book and showing what that is. Over here, what we get is a list of selected book IDs as a list of strings. You don't actually get the items. You don't get the item text. You get the IDs, right? So when something is selected, it goes into this selected book IDs. So we have to loop through these, grab the book with a little bit of link, and if it's not null, then we show it right here in a loop. Okay? So that's the code that we need to use it. Now let's look at the component itself. So it is actually doing a multiple here, but it's got a cascading value for child content, which is how it's going to render everything with a render fragment. Oh, by the way, this is the guys or gals, I'm not sure. This is their blog post that posts this code. Give them some credit. Ashkey98, ASHKE98 is this person who wrote this, and it's pretty clever. But there's a lot of stuff in here, right? So there's a lot of generic stuff in here. They're using on after render async, right? They're calling JavaScript. And let's look at that JavaScript. It's pretty intense, right? There's like 3 levels of if here. There's some cyclomatic complexity going on for sure. And this is what you'd be up against if you wanted to, say implement a feature that Blazor doesn't currently support and you want to do it yourself. This is the kind of thing that you'd have to do. Even this right here, this .NET object invoke async method, right? This is calling JS invocable, means that we can call it from JavaScript. So this is JS interop the other way around. All right. So all that is to show you that if you're going to do something yourself, it either requires you stumbling across the perfect solution on the internet, like I happen to do here, or it requires you using a third-party control. And here to show how you might do this in with DevExpress listbox control is Don Webier. Hi, Don.
Hey, Carl.
Hey.
That was a decent amount of work getting that multi-select feature enabled.
Yeah, serious.
But fortunately, there are easier ways of doing so.
Good.
By using the native DevExpress Blazor controls. And let me show you how simple that works. I have this page over here, and I have only prepared this property which will hold the selected books of the list box.
Okay.
And what I'm going to do, I'm going to insert the DevExpress list box here, where I will bind the data to the book service, and I'll specify a text field name, which will be in this case the property name, which will be displayed inside the list box. And then the last thing is I'm going to bind the selected items of the list box to the selected books property of the page.
Okay.
And this is basically all we need right now. Let me also include the code that you've seen before. There is one difference though, and that is instead of cycling through this list with IDs and stuff, you can now cycle directly through the selected books collection.
Yeah.
And you can write out those property names straight away. So it's again a bit less code here. And once I run the application, let's see what happens now. If I go to the DevExpress demo, what we'll see is that we have the same UI as we had on the previous pages. The only thing right now is that if I hold down the shift key or the control key, it still selects one. Well, and that's actually quite simple solved, because right now the list box is in single selection mode. If I go back to the code and I'll add a property which I will change to the list box selection mode multiple, we're all set. So let's run a demo again, and I will now be using my control and my shift key as well. And what you'll see is I can select items individually or deselect them, or I can even hold the shift key to select the whole batch. So that's quite simple, huh?
Yeah.
And there is one more thing I'd like to show, and that is setting another property. And that property is gonna be show checkboxes. I'm gonna put it to true, and now all of you may guess what this will do. So let's run it again, and what we have now is a really nice list box with checkboxes. And for signal selections, I don't even need to hold down the control key, but I can still use the shift key if I want. So if I want to select the whole batch, I'll just hold down the shift. So a very nice and powerful control.
Yeah.
And yeah, if we check the amount of code that was needed to get this desired UI, I would say this is too much, right?
No, it's just the right amount, Don. Thank you very much for that demo.
You're welcome, Carl, and we'll talk later.
All right.
Bye.
Thanks for all your help in the chats. All right. So now, what I want to do is make sure that our Zoom is set up completely and that Dan Roth is standing by. Yes, he is. I'm going to hide my self view, and let's pull on Mr. Blazor himself from Microsoft, Daniel Roth. Yay! Woo! I got to get some sound effects here.
Carl.
Yeah, thanks. Glad to have you. So we showed a little bit. I just showed briefly that preview page for Preview 4 WebAssembly. That came out. You said it was being released today, but your blog post said it was March 16th, right? April
Preview 4
April
actually
16th.
came out just a week ago. Like we shipped that on the 16th.
Okay.
And then today we just shipped another preview. We shipped Preview 5. So
What?
Preview 5 is now
I'm
the 2
too
new and latest,
behind.
greatest hotness.
Oh my God! I didn't know I was too behind.
We are moving fast and furious right now. We are basically moving in lockstep with the Visual Studio preview updates that are coming out for their 16.6 release.
Okay, let me see if I can. I'm gonna.
Updates as they ship up.
Sorry, I know this is jarring, but I'm gonna add myself to this conversation and move myself around so I can actually talk to you like you. All right, there we go.
That's cool.
Okay, so yeah, so you're on preview 5 right now. So bring us up to speed as to what you guys have been doing.
We've been doing a lot of stuff, basically finishing up the last remaining set of feature work that we want to do for the Blazor WebAssembly release.
Okay.
In preview 5, the new features are support for configuration, even in your startup logic. So
Yeah.
your program main function, you can now get access to config data that's being automatically downloaded for you from the server in your app settings.json file. So that's really nice.
Good.
You can then configure like your auth settings and those things like that
Mm-hmm.
in those JSON files. We also did a bunch of work in the authentication space to make it much easier to attach access tokens to outgoing HTTP requests.
Oh, nice.
So you showed a bunch of stuff with like authenticating users and
Yeah.
getting JOT tokens. Blazor now has built-in support for that.
Great.
And we've just polished up the patterns for how you use those tokens. You can now use a built-in message handler that will take care of attaching tokens to the outgoing requests for you and let you know if you need to redirect the user to the login page if the token is no longer valid.
Wow.
Expired and they need to get a new one.
Awesome. So all that stuff that Chris Saney did the hard way that I incorporated is now in the box.
It is all in the box. You just file new project. You can create a Blazor WebAssembly app that has full authentication set up, either using Identity Server, which is a great open source project.
Oh yeah, absolutely.
You can use Azure AD, you can use Azure AD B2C, or you can use any third-party OIDC provider that you like.
And you can still like use your own identity database with application DB context and manage your own roles and all that stuff too, of course.
Yeah, when you use Identity Server, we use ASP.NET Core Identity for handling the user logins, like storing the passwords and dealing with all the login concerns. Identity Server then just handles like the token issuing and all the OIDC concerns.
Yeah, good stuff. Okay, so what else is new?
Well, we're getting pretty close to being done. So we're going to have another release here pretty soon, which will be our release candidate release for the Blazor WebAssembly 3.2 release train, I guess.
So like mid-May?
That's supposed to be done by the end of the month.
Oh, by the end of the month. All right. So end of the month, we basically have a release candidate, right? That's what you said.
Fingers crossed, assuming everything goes well, that should happen.
Wow.
That's basically the build that we think we're shipping in May. We're still targeting a May release. Assuming that goes well, in May, we'll hopefully flip the brand to be 3.2 final stable, and then we'll ship that in mid-May-ish. When that's when you'll be able to use a stable and supported version of Blazor WebAssembly.
Very cool. So now, question there, when you do an update, sometime there are major features like this authentication stuff that you mentioned, and then sometimes there are just things that people expect to do that they can't yet do, like the debugging and stuff like that. Do you think like the list of major features that are going to cause you to rewrite code or maybe to use some of the code that's built in, you think that stuff is pretty much baked now, or are there still major features to be written?
There are no major features to be written at all, actually, at this point. I mean, the release candidate is basically done, so we're not doing any feature work right now. We're just doing polish, bug fixes. If you've been following the most recent previews, you hopefully can see that the amount of API churn has really slowed down.
Yeah.
An upgrade from release to release right now is mostly just a package update. We did have like one little API tweak in this last release, but nothing severe. And certainly from release candidates to the GA, stable release, I don't really expect any breaking changes there, just only quality of life improvement.
Right. And what's the state of debugging right now for WebAssembly?
Debugging in Preview 5 is, it's getting better. There are there's still some rough edges, I would say, in Preview 5 that you won't really see the fixes for until we give you the release candidate build.
Right.
But it's functional. You can hit breakpoints. You can see locals. You can step through code. You can step through code both in your the WebAssembly side of your app, like the code that's running in the browser, as well simultaneously as .NET code that's running on the server. One of the features we want to enable there in the tooling side is to also make it really seamless for you to simultaneously debug your JavaScript. So you can debug JavaScript sitting in a Razor class library in addition to your .NET code and step seamlessly between the two. That's coming in the
Wait,
next
did you say
release.
JavaScript in a Razor class library or from a
Yeah, so
laser?
when you from a Razor, well,
Okay.
both. Like when you write code in Blazor that needs to call into JavaScript, you often want to then take that JavaScript interop logic and package it up as a
Of
NuGet
course.
package and share
Yeah.
it with people. And that usually involves a little bit of custom JavaScript that you've written yourself. So
Okay.
there's a way in libraries for you to package the JavaScript with the library inside the NuGet package so that it's just available when
Oh,
people
great.
install that NuGet package.
So when you install the
Now, when you
NuGet,
do that, you
yeah,
want to be able to debug into it too, right? You want to be able to step into that code,
right.
and that's what's coming soon. Hopefully, in the next in the release candidate release in
Wow.
a couple weeks.
Wow, so amazing, so amazing. So, geez, what else is there? I mean, just polishing and getting the last few bugs out. It sounds like you guys are getting really, really close.
We are really close. After May, we will then start moving our attention to .NET 5. There was also a .NET 5 preview release that came out today. There's no Blazor bits on the client, like no Blazor WebAssembly bits in .NET 5 yet. The Blazor server stuff is there, but we haven't really focused a lot of attention on improving Blazor in .NET 5 yet because we wanted to finish up Blazor WebAssembly. After May, we will then completely shift our attention and move all the Blazor WebAssembly stuff into .NET 5, and then we've got a whole bunch of improvements that we've got planned for the .NET 5 timeframe.
So right now, if I'm using Preview 5 of WebAssembly and I want to add a NuGet package, just a Microsoft NuGet package, right? I don't want to choose the pre-release .NET 5 versions. I want to choose the latest stable version. Is that right? Or the latest pre-release that's not .NET 5.
I mean, with preview bits, I mean, if some people really like living on the edge and they want to try out all the latest, greatest stuff.
Yeah.
Right now, if you're playing with Blazor WebAssembly, I wouldn't generally mix .NET 5 and Blazor WebAssembly.
It doesn't work for me.
Really set up to, so one or the other is what I would say on a given machine. That will get all fixed up here in the next month and a half or so once we've reconciled what we've done with Blazor WebAssembly 3.2 and .NET 5.
I noticed that you said that you're going to add you're going to surface the focus and all of those kinds of DOM-y things into Blazor in the in the .NET 5 time frame.
Yeah, we want to make it so you write less JavaScript and more C# in .NET 5. There's a couple scenarios where today you have to write JavaScript, even though the scenario is pretty common, like setting UI focus is one, drag and drop, file uploads, doing anything with local storage, or messing around with the the HTML metadata, like setting your title, the header information in the HTML page. You have to drop the JavaScript for those things. It's not a huge pain, but it's not what Blazor was really meant for. You're supposed to write
sure.
not
I know. Yeah, exactly. I recently wrote some.
Try and make those scenarios
I recently wrote some JavaScript with interop to play an MP3 file, and it was only a few lines of JavaScript, but man, it would be cool just to have a media player component. Are you going to leave that up to the third parties, or are you going to surface that stuff as well?
So some stuff we will do ourselves. Like I think UI focus, that's so common. We will provide that support out of the box. For a lot of the other more specific JavaScript interop scenarios, we do lean heavily on our community. Like I said, you can write your own JavaScript interop code, package that up in a NuGet package, and share it with the world. Now hopefully no one has to write that JavaScript again in a Blazor application. Use your NuGet package. That is very intentional that we want that ecosystem, that community to thrive. So we don't plan to do everything, but for really common scenarios that pretty much everyone has to do, those should just be in the box.
Cool. Is there anything else that you wanted to say that I failed to ask you about? or questions that you got in the chat room that we want to shout out on the video here? I think you answered most of them, but
the people were a little quiet on the chat. I didn't see
yeah.
a whole lot of questions. If I missed any, we can certainly take a look.
Okay.
See a woot. We see yeah.
That's
all
okay.
Cool. I mean, you can always find us, of course, on GitHub. If you have questions or you're having problems with Blazor, or you have a suggestion on how to make it better, I'm also on Twitter at danroth27. And yeah, you know, we're just it's an open source project, so we try to be as transparent with the community and engage with the community as actively as we can.
Dan, am I out of line to be so excited about how beautiful and elegant the component model is? I mean, do you have other developers as excited as I am?
You know, I remember the first time I got to write a Blazor app. This was like, 2 years ago with the first prototypes that Steve Sanderson was working on. And I was like, oh my goodness, I feel like I can finally do front-end browser-based development.
Right.
And it was great. It was a euphoric moment.
Yeah, I'm still having that euphoria. And every time I go through that demo and show how elegant the binding is and how you can bind to events and they just work, it's just so easy. I've never been more productive building web applications than I have been in the last few months. So thank you, and thank the team for me and everybody else.
I will pass that along. I'm sure they'll be thrilled to hear that.
All right, Daniel Roth, thank you very much for joining us again on the Blazor Desk Show, and we'll see you out there.
Thanks, Carl. Thanks for having me.
You bet. All right, and that brings us to the end of tonight. Now I want to encourage you to please go to this URL right here, devexpress.com/freeblazor. They really want you to love their controls, and there's a lot to love there because they take a lot of the heft and the work off of your plate when it comes to doing real world stuff and getting stuff done. devexpress.com/freeblazor. Register right now, download your controls, and let us know what you think. Thanks very much, and well, what can I say? That brings us to the end of our show. We'll see you later. Good night, good morning, wherever you are.